Hey guys, and welcome back to another video on the channel. In today's video we're going to be looking at the Specialist Mathematics Paper 1 Tech Free Multiple Choice booklet for the 2023 external exam. So this is for the QCAA syllabus for Queensland and Australia. This is pretty much a tech free one, so all these questions must be done tech free, and pretty much let's just get straight into it pretty much. So front page, and you can also use the formula sheet as well, provided in the QCAA syllabus. So question 1, let's take a look at this. So the position of a particle is given by r equals t plus 2i plus t squared j, and for t has to be greater than 0. So this is your corresponding x coordinate and this is your corresponding y coordinate. We can see it's a vector equation telling you the position at different points in time. Well, I'm assuming it's time because I use t as the parameter. Determine the corresponding Cartesian equation. So this is your vector equation for your particle, but the Cartesian equation basically eliminates the parameter you have involved. So for example, we need to get rid of this t and replace it for x and y pretty much. So we get two equations from this. So we know that this is the x value, so x is equal to t plus 2. And we also know the y is equal to t squared, okay? So what we can do is pretty much make t the subject and substitute it into the other one. So what we got to do is pretty much get the t by itself, so square root both sides. So you have the square root of y equals t. Now we're not even going to bother writing plus or minus because we're going to get rid of that very shortly, and we're just going to substitute this guy into here pretty much. So we'll get x equals the square root of y plus 2. Then we're going to move the 2 to the other side, so we get x minus 2 equals the square root of y. Now we want to undo that square root because we can see in all of our answers here there is no square root of y, it's just y by itself. So we can just square both sides, so we'd have x minus 2 squared, and the square would cancel out the square root, so you get y equals x minus 2 all squared. So I'm just going to rub this out now because we're running out of room here. So what we have at the moment is y equals x minus 2 all squared. Now to pretty much see which option is correct, we need to expand these brackets. So this means this times itself twice. So it's x minus 2 times by x minus 2. And then we can multiply each term by each other. So x times minus 2, negative 2 times x, and then minus 2 times minus 2. So we get the following expression. So we'll get y equals x times x, which is x squared. Then we get x times by minus 2, so you get minus 2x. Then you have minus 2 times by x, so it's another minus 2x. And then you have negative 2 times negative 2, which is positive 4. So you can see we have two like terms in the middle, so we can simplify the whole expression. So it's x squared minus 4x plus 4, okay? And then we pretty much just look to see if any of these ones pretty much match. So we can see this matches very clearly with this one here, okay? So then the correct answer would be C straight away, okay? So with this question here, you pretty much just equate, say, all right, that's your x, that's your y, because those are your x and y components. So then you substitute for t, so you want to get rid of your parameter, so you have the equation just in terms of x's and y's, okay? If you have any questions about question 1, leave something in the comments and I'll try my best to answer it, okay? All right, question 2. So consider the proof of the following proposition using mathematical induction. So induction pretty much means you're proving for n equals 1, n equals 2, n equals 1, n equals k, and then n equals k plus 1, okay? So the appropriate assumption statement within this proof is, so when we're substituting n equals k involved, okay? So on this side here, I know straight away these first two are incorrect because they've chucked the k here where the r is meant to be. So what we're doing is replacing n with k, not the r with the k, because while this will expand out, these are your indexes for the sum. So what they've done here in these first two, the reason why these two are wrong is they've replaced the r's with a k. You're only replacing your n with the k, so those two are incorrect straight away, okay? Now, if we look on this side here, yep, they've replaced the n over here with k, but they haven't replaced the n over here, so that's also incorrect. So the only logical one could be left is this one here. And we can also double check here. Oh, yep, they've substituted k there, k there, k there, k there, where all the n's are corresponding. So we can see that is the correct answer, okay? So yeah, correct answer is C for question 2. If you have any questions about this one, leave something in the comments and I'll try my best to answer it. Alright, so let's take a look at question 3. So, one solution of z cubed minus z squared minus 7z minus 2 equals 0 is z equals negative 2. Which equation could be used to determine the remaining solution? So basically what we have is you've got one solution and they want to know pretty much what happens if you factorize this solution out of this one here, because we want to apply long division to it, okay? So if z equals negative 2 is a solution, then z plus 2 must be a factor of this corresponding polynomial here. So the equation we're going to get is what happens when we divide this by this equation here, pretty much. So what we were going to do is just set up a long division. So what we want is, alright, what would this be? This would be z plus 2 divided by z cubed minus z squared minus 7z minus 2, okay? So then we just do long division on this pretty much. So this term divided by this term, so that's going to give you z squared. So z cubed on z gives you z squared, and then you multiply the z squared by this thing here. So z squared times by z plus 2. This is going to give you z cubed plus 2z. Then we chuck this bit here underneath here and we subtract it. So this is going to be subtract this expression here. So z cubed plus 2, that's a z squared, my mistake, z squared. So we can see we've done it correctly because the first term cancels. So z cubed minus z cubed gives you 0. And then minus z squared minus 2z squared is going to be minus 3z squared. Okay. We also forgot to add the z squared up here when you're done with it as well. And then we just move the rest of it down below. So minus 7z minus 2. Then it's just repeating the process all over again. So divide negative 3z squared by z, which gives you minus 3z. Okay, and then you can chuck that up here, minus 3z. So we can see we're starting to get an equation up here. And we can take a look here. There's only two of them that have a minus 3z, okay? So the difference between these two is this one at the back, whether it's minus or positive, okay? So we know straight away that it's not going to be C or D, okay? So if you're in a rush, you'd probably guess at A or B, but pretty much we're just going to get the exact answer here, pretty much so we know which one's which, okay? So then you have this number here, so negative 3z times by this thing here, so z plus 2. That gives you minus 3z squared minus 6z, okay? I don't know why it's writing in red. I left it in there. Then you move this guy down here, so it's going to be negative 3z squared minus 6z. Subtract this thing here, and we can see we've done it correct again because negative 3z squared minus negative 3z squared is 0. Then we go negative 7z minus negative 6z. This negative times this negative is going to be a positive, so we're going to have basically negative 7z plus positive 6z, so that's going to give you negative z minus 2, okay? Then it's negative 1, negative z divided by z, so this bit here divided by this bit here, which gives you negative 1, so negative z divided by z gives you that negative 1. And we can see actually straight away, we don't even have to finish it, we can see straight away we've got our answer up here. So the correct answer to this one here would be A, okay? So this one here, pretty much, this would take a bit, because the general rule with multiple choice questions is try and do it as fast as you can within a minute. But as you can see, some questions here take more than a minute, but some questions might take less than a minute, so a couple easy ones, okay? If you have any questions about what I've done in this question here, leave something in the comments and I'll try my best to answer it, okay? So let's take a look at question 4. So the age-specific population distribution of a particular species of animal is shown. Okay, so it's got the female population, breeding rate, and survival rate. So we know straight away this is Leslie matrix. Okay, now Leslie matrix, how it's set up, it doesn't include the female population at all. That's its own separate matrix, which you would have like 94, 82, and the rest of those numbers there, yada yada. In a Leslie matrix, up the top, you're going to have your breeding rate. So your breeding rate should be your top row here. Then your survival rate should be down the column here, okay? So when I'm looking at the answers here, if I see the female population in this matrix, I know that's incorrect because it's got up there. Up here, we can see we have 1, 2, 3, 4. Where did those numbers come from? So that's also incorrect. Now let's take a look here. What they have here is two matrices that could be correct, because it's got your diagonal and it's got your top bit here. However, look what they've placed up here. So what they've placed up here isn't the breeding rates, it's the survival rates, because you've got your 0.6 and 0.6, and you've got a 1.3 and a 1.3. So they've switched the breeding rates and the survival rates. Your breeding rates need to be in your top row, so this here is your correct answer pretty much, and your survival rates are on the column. So the correct answer is D for question 4, okay? Right, let's go on to the next one. Alright, question 5. A confidence interval for a parameter is a range of values within which the, and then it has blah, 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 blah. Okay, so it is an estimate, okay? It's a sample estimate, because a confidence interval is basically taking a sample and saying, we're confident it's between here and here, okay? So we know it's not going to be C or D, because it's not just a parameter basing on everything, it's a sample estimate, okay? Now, a sample estimate basically means that the range of values are going to be within that interval. So they're always going to lie within that interval. So question A is the correct one. Oh, not question A, answer A is the correct one. A sample estimate of the parameter always lies, okay? Right, let's take a look at question 6. So question 6 looks a bit scary at first. However, we just need to break down what they're actually doing here pretty much. So don't even worry about the answers, just try and understand what they're going to say here. So what they're saying here is they're graphing pretty much a picture, and then they're putting pretty much a domain restriction on it. So this bit here is basically saying whatever this drawing is here, it has the real numbers of your complex values have to be less than 1, okay? So I have a feeling the picture is going to be a circle, because every single answer here is a circle. But let's understand why it's a circle. So just take a look. Let's use a yellow one. Let's just take a look at this bit here, okay? What's it saying? So ignore the z dot dot. We're just looking at this here. It's just an equation. So what we have is the absolute value of z plus 2i minus I, absolute value of less than or equal to 5, okay? Now, when you take the absolute value of something, so the absolute value of x means square root of that all squared. It makes everything positive, okay? So if we apply it here, or before we apply it here, we need to know what z is. So z is a complex number, okay? So your x values are real numbers, and your y values are complex numbers. So we have a yi. So that's the general form of pretty much a complex number, okay? And we can chuck that pretty much into here. So if we did that, we'd have x plus y, I plus 2 minus I, less than or equal to 5. We're running out of room here. Oh, we can start writing up here. So I'll just write it here. So x plus yi plus 2 minus I, less than or equal to 5. Get that out of the way now. Now we can see straight away we can add the real numbers and the complex numbers together. So what we can do is we could probably, or we can group these guys, and we can group these guys, okay? So we would have absolute value of x plus 2 plus y minus 1, or well, not a 1, minus 1 times by I. Then we can apply pretty much the absolute value rule we have here. So what we can do is actually square root everything and square each of the individual components. So y minus 1 all squared I, less than or equal to 5. Square both sides, so you get x plus 2 squared plus y minus 1 squared I, less than or equal to 25. Now you're probably wondering why I left the I. The I is the unit of the axis. The imaginary axis is in terms of I. So you don't really need to square root the I pretty much, okay? But you can see here, this is the equation of a circle. Now the center of this circle are going to be the opposite signs of these things here. So the center of the circle will be -2 and +1, so it'll be positive I, okay? So now we just see which picture matches it perfectly. Okay, well for starters, this one would be -2, and this would be positive I. This would also be -2 and positive I, so both of these pictures work. These ones, this would be +2 and -I, so the other way around. So neither of these are correct pretty much, okay? Now, the difference between these two answers lies within pretty much this restriction we've put here. So what it's saying is graph the circle, but only shade the region where the real numbers are less than 1. So this is 1. Now it's going to be less than 1, okay? So that means everything to the left of it, because to the left is smaller. So the correct answer is B, this shaded region here in the circle. Okay. If you have any questions about this one here, leave something in the comments and I'll try my best to answer it for you. But let's move on to the next one, okay? Righto, so question 7. At the moment, it looks actually quite difficult, but it's actually a lot easier than you think, pretty much, if you know your differential equations, okay? So, we're looking for a solution to one of these differential equations that gives us this general form here, pretty much, okay? So, all you gotta do is just pretty much go through and see, alright, which one is this gonna kind of give us here? Now, the first one, it's definitely not the first one, because notice your variable you're integrating with respect with. You're integrating with respect to t. You can see the t's right here. So you wouldn't need to rearrange this at all. You would just straight away just have y equals the integral, all this stuff here, dt pretty much. It'd be very easy to integrate. And it'll give us like a t squared or a capital T, etc. There would be no pretty much rearranging to get exponential at all, okay? This one here, you're looking for pretty much a differential equation where your variable you're not integrating with is not over here, because you want to do a separation of variables to get this thing here. Because remember, with the logistic differential equation, you have a dy dx equals some function of y. So you can do the whole change it over here, blah, 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 and then you can integrate it like that, okay? If you can't do this step here at all, then it's definitely not it. You can't do that here. You can just integrate straight up. You also can't do it here as well, because there's an extra t here, and it's still just something you just integrate on both sides. That is still exactly almost the exact same question. The answer is either pretty much this one here, or why isn't it highlighting? This one here or this one here, okay? Now, with a logistic differential equation, let's think about if we did integrate b, okay? Oh, that's not rubber. If we did integrate b, what are we going to get? So if we rearrange it, so we have dy dx, 0.5, that's a quarter, so I'll write that as a quarter of 1 minus 0.01 y, okay? So what you would do straight away, oh, that's a t, my bad, I'm used to x's, so let's put a t. What you would do is pretty much you would move your y's to the other side and have your dt by itself. So you would have dy, we could actually put a 4 there if you wanted to, on 1 minus 0.01 y equals dt. Now, when you integrate both sides at this point here, what we want, respectively, at the moment, is some weird looking thing where you pretty much have an Euler term, or like you have to do partial fractions over here. You don't need to do partial fractions on this side here, because you can see when you integrate this thing here, it's going to be a log, because it's got the setup like this. If you integrate something like that, they give you natural log of that thing there. But here, you don't need to pretty much do partial fractions. You can just do this rule here straight away. So it wouldn't be B at all. The correct answer would be D, because this one can allow for partial fractions, because you'd have to multiply that y out, and then you'd have some weird quadratic on the bottom where it's like y squared, blah, blah, blah. Okay? So it's not A, B, C, it is D. Okay? Now you could probably double check that as well. So I'm just going to do that very quickly to show you it's the correct one. So when you have, so dy dt gives you 0.25 y on 1 minus 0.01 y. So you would rearrange it so you get the y by itself. So you get dy on 0.25 y, 1 minus 0.01 y gives you dt. Then you can distribute that. So you would get dy on 0.25 y, and then I'm just going to use a calculator there because I don't want to stuff up the decimal. So 0.25 times by negative 0.01. So you're going to get, what would that be? Negative 0.0025. So negative 0.0025 y squared equals dt. And you can see exactly here, you would have to do partial fractions pretty much straight away. That would pretty much give you a couple of terms pretty much, but it wouldn't give you a log straight away, because remember, you want to do partial fractions with a logistic differential equations, because you can see from this setup here. It probably would be easier to actually leave it like that and then do the partial fractions, but this is pretty much what it gives you on the bottom, because if you didn't have this something here, then you're not going to get some weird partial fraction thing, okay? So the correct answer is D. Alright, so let's take a look at 8 now. If you want me to go into full depth on this one here, yeah, just leave something in the comments and I'll go into full depth. I can't go into full depth here because pretty much there's not enough room on the page for it. Just to show you in depth, okay? And you wouldn't really want to do in depth on the multiple choice, because remember, you should be knowing this as well off the top of your head with this multiple choice stuff. So you should know how the logistic differential equation should work because it's in the syllabus, okay? So let's take a look at question 8. So point A is the center of the sphere and point B lies on the surface shown, okay? So we have to work out the equation of the sphere. Okay, so with the equation of the sphere, we've got the center point here, so we know how the general equation is going to look. It's going to be x, and it's going to be minus 1 squared plus y plus 0 squared, so it's just going to be y squared plus z, and that's going to be opposite sign of that, so plus 1 squared equals the radius squared. Now we have to work at the radius. Now a lot of people would just go, okay, -1 and -5, that gives you 4. No, it's a vector. So it's going to have like a slight slant to it. So you have to work out what this vector here is. So the vector A to B is your radius, okay? So A to B is -O to A plus O to B. So A to B is -1, 0, -1 plus 1, -3, -5. So this gives you, well, that would give you 0. That would also give you, that gives you -3. And this would give you -1 times -1 is +1. So +1 plus -5 is -4. Okay, so that would be A to B. So, well, the radius is the length of A to B. So you have to find the length of this vector. So A to B is going to be the square root of 0 squared plus -3 squared plus -4 all squared. So this is going to give you the square root of 9 plus 16. So it's going to give you square root of 25. So it's going to be 5. Okay. So your radius is 5. So r is 5. Therefore r squared is 25. Okay. So now we can rub this out because we're not done the question yet. Because look how the equations are set out. They're not set out pretty. They're not set out factorized. They're already expanded. So you've got your x squares, your 2x's and stuff there, down the page pretty much. So what we need to do is with our equation of the sphere, we need to expand it and see which one matches perfectly, okay? So we can go, our equation of the sphere is x minus 1 squared plus y squared plus z plus 1 squared gives you 25. So what we're going to do now is expand this, and what we're going to do now is also expand this pretty much. So this would be x squared minus 2x plus 1 plus y squared plus z squared plus 2z plus 1 equals 25. Okay. We can see straight away we can move this one and this one here, so I'll highlight them so they're a bit more obvious. We can move both of these to the other side, so we get x squared minus 2x plus y squared plus z squared plus 2z squared. So 25 minus 2 is 23. Okay. And then we just see which one matches this guy here. So you can see straight away these bottom two aren't correct because they have 25s here. So it's either this one or this one, and we can see straight away it is A. Okay? Right. So let's take a look at the next question now. Okay? So what would that be? Oh, there's the mouse. Question 9. So the geometric interpretation of a system of 3 equations with no solution is shown. Okay? Given the two equations are x plus y minus z is 0.5 and x minus y minus z is 0.5, the third equation could be. Okay, so this one is tricky at first because there's 2 possible answers you could pick. Well, there's one correct one, but there's 2 main ones a lot of students will pick. So we can see 2 of the planes are parallel. So that means you want to see which of these guys here matches up exactly with this guy here. Okay, so first of all, these 2 aren't parallel because their normal vectors are different, because we can see straight away that this has a positive y and this has a negative y. So they're slightly different, so they're not the same thing. So what we're trying to look for is pretty much, alright, out of these planes here, so out of this pink one and out of this red one here, which ones are parallel with the ear? Okay, so straight away, this one here is parallel exactly with this one here. But it isn't just parallel, it's the exact same equation. Because if I had x minus y minus z equals 0.5, if I times that whole 1 by 2, then I'm going to get 2x minus 2y minus 2z equals 1, which is the exact same equation here. So it's not this one. Even though it's parallel, it would mean this guy here is sitting directly on top of it, pretty much. Okay, so that's not the correct answer. The rest of them aren't parallel at all. Well, this one is parallel to this one, but it's the exact same equation, so it's not that one either. This one is, which one would this be? It's not parallel to either of them, so it's incorrect. And this one, it's parallel to this guy here, but it's got a different number there, so that means they're not on top of each other, so it means a situation kind of like we have here pretty much. So D is the correct answer. Okay, righto. So now what we're going to do is just try and take a look pretty much at question 10. Okay, so a random variable is drawn from a population with a distribution shown in the histogram. Okay, so frequency, number of sample sizes of 10 were randomly selected from the distribution and the sample means X were recorded. The histogram that most likely represents the distribution is. Okay, so for starters, when you take a sample, it's gonna pretty much start to look like a normal distribution. So we're kind of looking for a shape like this or this or this. Okay, so it's not this one here, even though it's tempting. Okay, because look at all the figures, they're all messed up. So it's less here when it's actually more here, and it's high here when it's actually less here, etc. So it's definitely not A. Okay, now with this guy here, we need to look at the spread of data. The data is spread more towards the left, so the bell curve is going to kind of be around here pretty much. So it's going to be a bell curve, but it's going to kind of be around here. Both of these ones here are directly in the center, so that doesn't match and that doesn't match. So straight away I know it's B, because it's a distribution, but it's directed towards the statistics. There's a lot of stuff here, so that makes sense why it's shifted over this way here. Okay, yeah, and that's about it for this external exam video. Okay, if you have any questions about the questions I've covered in this video, leave something in the comments and I'll try my best to answer it, but I'll see you in the next one. Okay, see ya.